What's up, YouTube? This is the seventh long form video on Kyle's global weather. Today we're going to be talking about East Africa and specifically Cyclone Hidaya. It has been plaguing the region over the past week, killing hundreds of people and dumping heavy rainfall over the region, with strong winds, ocean winds, and so much more. And we're going to break it down into many different segments. Just to remark on some of the past videos, I'm really happy about the traction that we got on our last short. We got over 7,000 views, and that was the first short I had ever uploaded. So I really hope that continues in the future. That was great to see. I really want to make this video just to highlight the weather aspect of this. When I'm looking all over YouTube and on the news, I don't really see this being broken down specifically, so I really wanted to make a video so that I could do that for you guys. I know it's been a while since I've made a long form video. This is going to be a busy time of the year for me, but I really plan to try to put out videos as much as possible. In a few weeks, should be back to normal. Should be one long form video per week. So just letting you guys know. But let's get into it. So for maybe the first half of the rest of the video, I'm just going to be breaking it down in terms of the weather. And then we're going to delve into what's really going on now. Then some news outlets, like some first person perspectives on really how the cyclone is affecting people. Then we're going to do a forecast of the region, right, in East Africa, and then we're going to end it off with our normal tri-state forecast. So the first part is going to be examining what oscillation patterns in which specific phases could, in theory, cause like an enhanced East African long rain season. And this long rain season is anywhere from maybe March to mid to late May. So we're in that right now. That's what we're going to be focusing on. And we're going to be splitting this up into different things. First, I'm just going to tell you a little bit about the oscillation pattern in general, then the different phases, then which phase specifically pertains to what we're talking about today, and then some studies to back it up, and then a tracker to support that. We're in a specific phase of the oscillation pattern right now. So the first one is the AMO, or Atlantic Multi-Decadal Oscillation, and it has to do with ocean temperatures over the broad region of the northern Atlantic Ocean. Ooh, looks like I messed it up. This is, all right. Phase 2. Sure. This is a negative AMO pattern. You can see cooler waters over near the more equatorial areas, and then warmer waters right around the 30-degree latitude mark, and then cooler waters, a lot cooler, just north of that, around 50. And then the other phase, is pretty much the exact opposite of that. And it's what we're in right now, actually. We're in a positive phase, and I'll show you on the tracker in a second. And this is what specifically affects East Africa just a little bit. As you can see, the warmer waters is spanning all over the mid-Atlantic Ocean, and that's going to increase rainfall over Western Africa. As I've explained in my fourth long-form video, warmer waters can lead to more moist and more potent storm systems. And so, although this really doesn't impact East Africa directly, some of the moisture could make it over the continent in theory. So this would be preferable for an intense East African rainfall season, long rainfall season. There's not that many studies on this. This was one of the only ones I could find. And here's the tracker. What you really want to be focusing on is the numbers on the right. The number at the bottom suggests that the difference in ocean temperatures is over 1 degree Celsius in terms of the anomalies or differences from normal. So that's what we're in right now. It's April 2024, over a degree in Celsius. This is the second one. And after this, there's still going to be 2 oscillation patterns I'll describe, and they're going to become increasingly more relevant to East Africa. This is this southern annular mode, and it has to do with the placement of winds in the far southern hemisphere regions. And it can alternate just about every few weeks, or it could have longer periods of around a few months. So this is just showing what happens in Australia, and this is basically the region that it affects most, along with maybe the southern tips of Chile and Argentina, just because no land is really this far south, but it does affect East Africa in a mild way. A negative phase is characterized by winds being further north than usual and being just slightly weaker, and this happens more frequently with an El Nino pattern. We're going to get into that a little bit more. This is a positive phase. It's characterized by the stronger winds being positioned further south than normal. And mind you, this goes across the entire southern hemisphere around the 70-degree latitude lines, in the upper portions of the atmosphere. So this wraps around the entirety of Antarctica, not just Australia. I couldn't find a neutral phase, but you can kind of envision this purple line is where some of the winds will travel, and that's kind of what a neutral phase would be like. And this is what is probably most conducive to an enhanced long East African long rain season. It might seem counterintuitive, how can a neutral pattern really enhance or just be the best candidate for stronger rains? Right? It's neutral, it doesn't have any extremes. Well, the positive and negative phases each kind of have their own problems, and it's really complex. And it's something I honestly don't really understand, but essentially when you have these stronger winds, it'll affect winds in other regions. There's something called the Hadley circulation, which affects the transportation of winds between different latitudes. And so when this is displaced, essentially it leads to the winds being further north or south in kind of the 30-degree latitude areas, which is almost where East Africa is. It's around 10 to 20 degrees below the equator. So when that is messed up, it doesn't allow storms to develop as often potentially. But it does have an effect if we're talking about the short rain season, which is in October through December, but right now we're in the long rain season. And it's because of a strong winter subtropical jet. That's the reason why it doesn't really affect it in this time of year, as you can see it on the right. The studies on the left really just talk about the influence of it on the East African short rain season, but that's not what we're in right now. So this one doesn't have too much of an effect. So this was from a month ago. As you can see, we have data up until the very end of March, but then it just becomes so sporadic. And this just shows how unpredictable it is, right? We have very little clue how to predict it in the future. You can see it varies by 3 to 4 on the scale over there, and that's the position of latitudes, right? So 4 positive would mean that it's 4 degrees in latitude further north. And this stuff is very relevant to Australia, but it's not as much to East Africa, at least in this time of year. Okay, this is the ENSO, the El Nino Southern Oscillation. And this is potentially the biggest oscillation pattern in the world. I'd like to do a future video on it to really break it down for you guys, but that's not what we're going to be doing right now. You guys probably know this as it is, right? So a La Nina period is characterized by warmer waters in the western Pacific, and an El Nino is characterized by warmer waters in the eastern Pacific. This pattern can oscillate about every few years, but it can even be as frequent as a year or two. And there's even different degrees of these phases. A lot of times you'll hear things like moderate El Nino or weak El Nino or strong El Nino. Right? These are all about the different departures or anomalies from average of the ocean temperatures. If it's a greater departure from average, then we say it's more strong El Nino or La Nina. And then this is more conducive to greater East African rainfall, this El Nino. If you look at a global scale, you see the colder waters are positioned over the western Pacific in areas like Indonesia. This is important because what I'm about to get to later is something called the IOD, and it has to do with the ocean temperatures around the Indian Ocean. So if you can visualize it, there's cooler waters around Indonesia. As you move further west, it's going to be warmer. And these tend to line up, actually. the El Nino and warmer waters in Western Africa, in Eastern Africa. Sorry, this is just a good visual, right? If we see there's cooler waters here, if we move just a little bit further west, it's going to be warmer waters a lot of the time. And this is neutral conditions. I couldn't find an image that was like the other ones, but yeah, this is just for whatever you want to do with it. So the IOD is our next oscillation that we're going to be talking about, but this study suggests that over 1/3 of IOD events can be explained by this variability. So even though this is something that's in the literally the other side of the Earth, right, almost in a 180-degree rotation in some parts of the oscillation, it has a great effect on it. And the IOD is something that really impacts East Africa. It's one of the main effects of the IOD. So here's the tracker. We were in a moderate El Nino phase, as you can see on the top right here. This is the ocean temperature anomalies in Celsius. We were around 2 degrees Celsius for quite a few months, but now it's returning to neutral, and some forecasts say that we could be in a La Nina pattern towards the end of this year, even in the fall, as early as that. So this is what's most relevant to our East African region. It's called the Indian Ocean Dipole, and sometimes we don't even know if it's an oscillation pattern because it's more local than all the other things that we've been talking about before. Only around 30 years ago has it been recognized as something that could potentially exist, right? Not even everyone acknowledges it. But it just exists, but not as an oscillation pattern potentially. But these are the different phases of it. This is a negative phase, and it's characterized by cooler water in the Western Indian Ocean and warmer water in the Eastern Indian Ocean and around Indonesia. As we learned about, and I believe the 6th video, we talked about the land-sea recirculation, and how it's basically the transport of winds from cooler waters to warmer waters. And this is because when water is cooler, the winds above it are going to end up cooling down. Cooler winds have slower moving molecules, and that contributes to higher pressure a lot of the time. We discussed in other videos that higher pressure air tends to move to lower pressure air. And even though this is magnified like 1,000 times to like a coastline, it's basically still the same principles. The air is going to move towards the east at a broader scale. And this is a positive phase, which is the exact opposite. So not only do you have winds reversing from west to east in this scenario, but you have warmer water situated right above East Africa, which again is conducive to storm systems. And that is what we're in right now. And then the third phase is a neutral phase. So it's kind of in between, really weak like correlations between the ocean temperatures. Here's some studies, and it's really the main driver of East African rainfall. And this is a tracker by the Australian meteorology website. It suggests that we're going to be in a slightly positive phase for the next few months. Here are some other patterns. We can talk about ocean currents and their strengths and how they impact East Africa, but that's verging on being too much for this video to cover. And then we have the Madden-Julian oscillation, which is a little bit more relevant, but again, something that I couldn't cover. And a lot of these are closely tied to the phases of El Nino and IOD. So whenever it's going to be, like an El Nino, for example, a lot of the time it's going to be a certain phase of this, and it's kind of a cascading effect of the El Nino, so it becomes a little bit redundant potentially. So a lot of these patterns we don't fully understand in meteorology. A lot of the times we just observe patterns and we just say that like certain phases affect certain weather, which is a valid thing to say, but a lot of the times we don't understand the full scope of how it really happens, right? With an El Nino, it's really on the like complete other side of the world, and it obviously like makes sense, right? The analogy I explained before, but there's like lots of other things that I could talk about For one, if you want to Google it right now, it's something called Rossby waves. Right? We don't know exactly how El Nino affects that in East Africa, right? Or if it affects it at all. So it's really nuanced and deep and like sophisticated that there's like a lot of things that could still be unknown. So we're gonna move on to the second part of the video, which is what's currently going on. And I've talked about the broader oscillation patterns, but I really want to bring to you like the weather and where the cyclone is positioned right now. This is a forecast from just a few days ago. The storm was essentially taking a dip southwest, but then it recovered and moved further northwest. But right now we're almost in this western area, right? The storm is almost dissipated, but it still has a little bit of juice left to go. It was at its peak just around 2 days ago in terms of wind. So now we're going to look at specific data. I'm going to just quickly glaze over a bunch of different metrics. The first is CAPE, which stands for Convective Available Potential Energy. And when we look and see higher values of CAPE, that increases the odds of things like thunderstorms or tornadoes or supercells, which are like really small and intense rain showers or snow showers. When we see those, that's what we're going to expect. But I want to really bring it into the past of the development of the storm. So this is May 1st. We can see values of CAPE around 1200 to even 1400, which gets into the moderate range. And as this progresses, we can see these values peaking and then slowly dissipating as the storm eventually makes landfall, which is kind of where we're at right now. I also want to bring you to total precipitable water. And it's one of the ways of saying that if we have this much water in a given region, how much of it could potentially come out as water vapor or as precipitation? So if we bring this back, we can see these values were really, really high, right around the southern area of the eye of the storm. Right, 70, I'm not sure exactly what this means in terms of like American units. I don't know how to visualize that. Even if it were American units, I wouldn't know how to visualize that. But all I know is it's like 20 to 30% higher than some of the other regions, or than what it should be normally. So, and this is total cloud water. I thought it was total cloud coverage, but it kind of has to do with the thickness of the clouds. And as you can see, the weight is like over 2 or even 3 kilograms per meter squared, which seems really high just like for clouds to be that like dense, right? It's really just air for most of it. If you bring it to areas where it's blue, obviously that's sky, 0, right? But if we bring it over here, 2 to 3 kilograms per meter squared. So that's the data that's going on right now. It's really scary what's happening. Here's what it looks like from space. It's pretty big, right? It covers, this is Madagascar down here, and this is Somalia at the top. And the clouds like almost cover the distance between those two, and it's even further out west to east. It's only around an intense Category 1 hurricane if you were to compare the wind speeds, but the fact that it's traveling over such warm waters, and it's occurring during this rain season, so a lot of the metrics are more conducive to rainfall. These things make it that it would just be like a lot worse than normal for a Category 1 storm. I'm not going to show these videos. It's kind of scary, right? Like, you really just don't want to see this stuff. But you get the idea, like hundreds of deaths, tens of thousands of people displaced. You can see these images. It's not a video. People's just homes just destroyed. Right? This is really bad. If this kind of thing were to happen in America at the same degree, you wouldn't stop hearing about it. Right? If it's just hundreds of people just killed, thousands displaced. and I even brought it to a Tanzanian weather website, and there's just so many of them, but they're all reporting about this. Something cool to see. It's kind of like we're bringing it back to one of those videos where I looked up sites in Japanese and Korean. So that's what they're talking about in the region. Here's back to the same website, but I'm just going to use this to explain what's going to happen in the future. Here's really what we're talking about in terms of the rain. As we bring this back, we saw a really tight area of intense rainfall over a period of time. This area eventually made it over land around today and like a few days ago, but this is like insane. This is around 24 hours ago. Here, let's get it to load. Right, 150 millimeters. So that's around half a foot of rain in like a 3-hour period, and this is continuing for just hours and hours at a time. And this is, really close to a lot of major cities, right? Like the Eastern Seaboard. That's where a lot of development is in Tanzania. You have cities like Dar es Salaam getting affected too. It's very concentrated in terms of population. And this eventually dies out. We don't see these pockets of rainfall for much longer. But yeah, it really dissipates. But in terms of the real immediate future, it's only the real coastlines that are going to be affected by it. But look at this winds, right? This is surface winds. And, this is right off the coastline, but right on the coastline over here, it could be like 20, 30 kilometers an hour, which I know is nothing too crazy, but it's going to make things a lot harder, and it's going to influence. There's already lots of water on the ground, so that could really impact that. Here's a forecast on a broader look of Africa. We could bring this into the future. We see the low pressure system being replaced by high pressure, and then eventually dissipates. And what we're left with is clear conditions for the region. Hopefully they have time to recover just a little bit before something else may arrive. But it's good. Over the next 10 days, we don't really see anything major breaking out. So that's that. I know I was a little bit upset talking about that, but because we got to make it more serious, right? We can't have like such a slightly happier tone when we're talking about that kind of stuff. It's really sad, right? If it were to be happening in America or something, like we receive so much more coverage, everyone would be hearing about it. So yeah, that's that. Then we're gonna bring it to the tri-state forecast. We're gonna start out with our usual height anomaly map. I plan to use this for like a lot of the videos. This is not going to be as good as describing what's about to happen, because you can see there's all these higher heights in the eastern portions of America, which are usually associated with higher pressure, but it's a little bit different with this. We would have to move to a different height to really see like what's going on here. But again, remember these squiggly lines that I talked about? That indicates instability. And there's a little bit of storm systems that are bringing its way up, not just from the Central Plains, but from the Gulf of Mexico. There's just going to be a parade of moisture coming in. And that's going to last for maybe a few days. But through that time period, we're going to have lots of cloud coverage, and it's just not going to be nice. But we're going to have warmer temperatures. So I know that's something that people have been looking forward to. It's been a slow start to the spring in New York City and in the tri-state region. So here's a precipitation map. As you can see, like there's little onslaughts of moderate to light rain, but as we get into Monday morning, maybe a few bursts of heavy rain, right, for the New York City region, for Jersey. I'd say it would affect areas of New England a little bit more. I think it's a little bit too south, but we'll see. We'll see what happens. And then we have like a slew of rain just going over the south, and that doesn't end up making it north. And yeah, that's about it. Like it could be some mixed conditions, but this is what's normal to be expected of spring. So yeah, here's the cloud coverage for the next few days. Before this, it was around maybe 50%. Yesterday it was maybe 0% at some times. But as we keep this going, it's around 100% for a few days, and then it ends up clearing up around Wednesday, and it just keeps fluctuating. So that's pretty cool. I remember last time on the long form video, I predicted that it would be a lot cooler, and I was exactly right. It was actually 5 degrees Celsius cooler than what the Weather Channel had predicted. So that's something pretty cool. That was just my intuition, and that was for like Sunday, the 16th or something like that. I don't know exactly when it was, but so here's the forecast. The Weather Channel corroborates with what I've been saying, predicts rainfall. I think they're going to bring this probability up. I think it's a little bit higher than 24%. Here, let's give another prediction. Okay, a lot of times you'll see this like raining the whole day. That's not what that means. It's just raining at some point. I think there's going to be some intermixing with sun for some of these hours. All right, so that's my prediction, right? I think you might see some cloud coverage for these days, but the majority of the day could be like partly cloudy to sunny, honestly. Through these days, like it's not going to rain that much 5 days in a row. I just don't see it happening. And that's about it. I think this is around 20 minutes. So, I remember last time I made a video that was like 25 minutes. I said to you guys, like, I don't plan on making a video this long. So maybe I lied to you. We'll see how long it's going to be. Another thing is, this is a little bit more serious. On this short, I had some negative comments, and I'm not happy about that. Right? If you have something to say, you can say it, right? Freedom of speech. But if it's something that's negative that just like doesn't really take into account what I'm saying, or it's like just going after me as a channel, right? I'm gonna delete your comment, and I don't really care. I think if you point out something that's reasonable, right? I think that could be just as valuable as like an encouraging comment, but that's not what I saw. So yeah, that's why I deleted some comments there. My mission is to provide you guys with like really accurate stuff. And in the future, I think it's important to really cite my sources and give you guys, the areas where I'm getting my information from. So I'm going to continue to do that. But yeah, like I'm just not happy with that. So yeah, I hope you guys enjoyed the video. Please leave a comment like about what you want to see in the future. Because I'm really just choosing what I want, but I want to hear your input. I have a lot of ideas, and I want to see if your ideas, could really bring me some inspiration, right? Because I want to feed you guys information that you want to see, as well as the things that I care about. So I think that's cool. Wow, this is 28 minutes. So yeah, I guess I lied last time. This is the longest video. Okay, hope you guys enjoyed that. If you have any family or people down there, please wish them well. It's going to be a hard couple of weeks recovering from this. And that's about it. All right, see you guys in the next one.